Hello, everyone. We are very happy to have Mahshid today. She wants to talk about trends, seasonality, cycling, and outliers in time series analysis in our software. So we are very happy to have her and also happy for your attendance. So the stage is yours.
Hello, everybody. Warm welcome from our ladies to all of you. Herzlich willkommen von den Our Ladies an alle. خوش آمد میگم به همه از طرف Our Ladies. شروع میکنیم. We start. Today, yes. Today we are going to talk about time series characteristics called trend, seasonality, cycling, and outliers in time series analysis. Okay. First of all, we have a brief definition of time series. A time series is a sequence of observation which are indexed in time order. And some of the examples of time series in hydrology can be rainfall, wind speed, discharge, temperature, sunny hours, or velocity. That can be categorized in different kinds of time interval, like hourly, daily, seasonal, 6 months, monthly, or yearly. But please note that one important point is that we have to know why it is important to recognize the time series characteristics before doing any operation. The reason it's so important. In hydrology, time series analysis is vital for predicting river flow patterns, facilitating efficient water resource management, assessing drought and flood risk, contributing to sustainable water infrastructure planning, and real-time monitoring to changing hydrological conditions. So this is so vital for about identifying the time series characteristics before doing any operation. Each time series has 4 characteristics. Contains trend, outliers, trend, seasonality, and cycling. And we have to, after identifying them, we have to remove them from the time series. Okay, outliers. Outliers in time series data are values that significantly differ from the patterns and trends of the other values in the time series. And this is a simple graph how we can recognize them in our programming language. There are 2 different kinds of methods, visualization and numerical methods. Visualization contains 3 different kinds of plots: box plot, histogram, and QQ norm. And numerical method, if we want to use the numerical method for finding the outliers, we have to calculate the average and standard deviation. And please note that all of the methods will be explained in detail after finishing the slides. We will go through the R and we will explain them in details. They are just an introduction. Okay, what is a trend? The trend represents the long-term change in the level of time series. This change can be either upward or downward. For identifying trend, again, we have 2 different kinds of method. By visualization or using statistical method, we can recognize the trend. Visualization contains plot and drawing a line, and statistical method can be Kendall. Kendall is a statistical method. Seasonality. Seasonality is the presence of variations that occur at specific regular intervals, such as weekly, monthly, or quarterly. Seasonality can be caused by factors such as weather or holiday and consist of periodic and repetitive patterns in a time series. Cycling. Cycling is the presence of variations that occur at non-specific regular intervals. So please note that it must be highlighted that a big difference between seasonality and cycling is a cycle occurs when the data exhibits rise and falls that are not of a fixed frequency, but seasonality is always of a fixed and known period. For analyzing seasonality and cycling, we can use same methods. We have autocorrelation function method and decomposition. And the package which we are going to use them in this section are readxl for importing the data, dplyr for filtering, Kendall for trend analysis, and T-series for decomposition. This is just a brief introduction. Now we are going through the R programming language. We have some examples, and we will explain every characteristics in details and also every package. Okay, first of all, by using the readxl package, I've imported our time series. Here we have a monthly time series of a hydrometric station in Germany called Steinberg. And okay, it contains 260 observation. Okay, now I think it's better. Okay, our time series contains 216 observation, and the class of our data is a data frame, and this data frame contains 216 rows and 1 column. Okay, so this is a monthly time series. We are going to find at first finding the outliers. The first method for finding the outliers is visualization. By visualization the data, easily we can find which one is out of the pattern, which one isn't normal in our time series. Okay, so the first one is a box plot. Please pay attention that the class of the data is data frame. So if I use the data frame time series, I can easily plot a box plot and recognize the outliers. Here, there are 4 data which are not normal and they are out of range. So now I know that in this time series I have 4 outliers. Okay, but just the number of the outliers, not the exact place of them. Okay, if I want to know more detail about the outliers, about these 4 outliers, I can use this code. And by using this code here, I have a section called out, means outliers. And they are the exact amount of these 4 data, the exact amount, but not the place. Just I know the amount of them. The second method is drawing a histogram. But please be aware that if you want to have a histogram of a time series, you have to work on, you are not allowed to use data frame. So that's why I've changed the class of data frame to time series by using TS. Now I have a time series and I draw the histogram. Okay, so you can see that again, we have 4 outliers. But again, just know about the number of them, 4 outliers. The third graph is QQ norm. Again, QQ norm is able to apply on time series, not okay. This is a QQ norm. In a QQ plot, all of the data should be dense. And if some of them are out of range, here in this example, we have 4. So these are the outliers. Okay. If we want to, if I want to show all of them in one graph, you can use this code, and by using this code here, we have 3 different kinds of graphs which are able to show the outliers. Histogram, there are 4. A box plot, they are 4. And in a QQ plot, again, we have 4 outliers in this example. Okay, now so far, we know that there are 4 outliers. Now I have to remove them from the time series. For removing them, I have to know the exact place, the exact number of the rows of the outliers. So I have to find the number of rows. This is a code which we can share our script after the section by using which function you can find the exact place of the outliers. Okay, I've named it outliers, and if I check the length of the outliers, you can see that this is 4. That is 4. Okay, would you please?
Excuse me, wait a second, because we have. Excuse me, Mashid. We have someone who is just, I think, trying to do something, so I'm trying to remove him or her. Wait a second. Okay, then I also want to just delete the Zoom link in this way that no one can join. Sorry for interruption. Go ahead.
Okay, good. Okay, so I've called it outliers because we are going to find the exact place of the outliers. And as you can see, if I check the length of the outliers, it shows 4. It means that we have 4 outliers. And now about the exact place of them, yes, and here, this code can show us the exact place of the outliers. It means that we have 4 outliers which are placed on 26, the row number 26, 111, 133, and 145. So now, okay, so now we know about the number of outliers and the exact place of them. In the second step, I'm going to remove them from the time series. For removing the outliers, we can use filter function. And filter for using the filter function, you have to use the dplyr package. Okay, so I've uploaded. And then by using this code, I filter the time series and removing these 4 data. And now if we check the second time series, which I've called it Steinberg 2, we have 212 rows. But in the last step, we had 216. It means that here we've removed the outliers. And yes, so this is the explanation of finding and removing the outliers by visualization method. The second method is numerical method about outliers. For numerical method, we have to calculate the average of the data and the standard deviation of the data. So I've called them mean and STD. But please be aware again, if you want to use the numerical method, you have to use time series, not a data frame. So that's why I'm using Steinberg TS. Okay, this is the average and this is the STD. Okay, the next step is that we have to define a threshold. We have to define a threshold for finding the outliers. It means that we have to define a threshold. If any of the data is in between, they are the time series which we wanted. And if they are out of the threshold, we called it outliers. So I defined T mean and T max. Usually, by subtracting the average of 3 times the standard deviation and adding average to 3 times the standard deviation, we defined a threshold. This is a usual method which scientists use it, but it totally depends on you, and some of the scientists prefer to use 4 times STD. It's totally depends on the field. We are talking about hydrology time series. That's why I introduced 3 times STD. Okay, so now I defined the threshold. Okay. Now by using this code, we have to find the outliers. It means that by using the function, which function, it means that go through the time series and find the data which are less than T mean or more than T max. Okay, at first I have to find them. If I run the code, you can easily find the outliers, but the difference is that in the visualization method, we had 4 outliers, but in the numerical method, we find 3 outliers. It's because of the threshold. It's because of the threshold. Okay, now I want to remove the outliers. I know them, I know the amount of them. Now I have to remove them. For removing the outliers by using the numerical method, again, I use which function. It means that go through the time series and find the data which are more than T mean or and less than T max. So it means that I'm trying to find the data which are in between the threshold. So if I check the length of the outlier, I have 213. It means that this method removed these 3 outliers from the time series. Okay, so this is the numerical method for finding the outliers and visualization method. Now we are going to talk about the trend, the next characteristics. For finding the trend, we have statistical method. For statistical method, we have to use a statistical test. The most famous one in this field is Kendall. So we will use the Kendall package. And again, be aware that we have to use time series, not a data frame. So that's why I've applied the code on the time series data. And okay, in this statistical test, null hypothesis is there is no pattern in the data, and vice versa, there is a trend in the data. In this example, the p-values is more than 0.05. It means that null hypothesis is completely acceptable and there is any pattern in the data. Okay, and also we have another example about having trend, but in this example there isn't any pattern, so you have to refer to p-values. And about visualization method. About the visualization method, you can easily plot the time series by using plot function. Okay, I have a plot, and then you have to draw a line. Okay. If I draw a line and the red line shows a upward trend, I can say that, okay, there is an upward trend. Or if the red line shows a downward trend, we can easily say that there is a downward trend. But here in this example, as we tested with Kendall test, there isn't any trend. You can see the results also in by visualization, the data. The red line is straight, so it means that there isn't any trend. But also we have another example. I've prepared another example for better understanding of the trend. If I plot it, I've called the new example trend underlying data. Okay, I plot it, and you can see that yes, there is an upward trend. And if I draw a line, the red line shows an upward trend. It means that there is this time series has characteristics which has to be removed. And for the second example, also, if I want to use the statistical method Kendall, I've applied the Kendall, and as you see, p-values is less than 0.05. It means that null hypothesis is rejected, and there is a trend in the data. Okay, so for removing the trend from the data, I've introduced two methods. The first one, and the most famous one, is taking logarithm. I've called it one, and so it just easily apply logarithm to the time series. And now if I draw the red line again, we can see that again we have the upward trend. So it means that this one is not it's not a suitable solution for our time series. So we have to use the second solution. The second one is difference. It means that every data, by subtracting every data from the previous one, we will have a new time series. And if I plot it and a red line, you can see that the trend, now the trend is removed, totally removed, and the red line shows any trend. Okay, so this is the second solution, second way. And just for showing the statistical method, if I run the statistical method for the second one, you can see that p-value is more than 0.05. And it means that the null hypothesis is acceptable and there is no pattern in the data. So the trend is removed and the time series is ready for the next operation, for modeling or anything else. Okay, now seasonality and cycling. For seasonality and cycling, we use the same method for both of them, numerical and visualization. The most famous way for finding and removing seasonality is decomposition. I've used the T-series package, and one of them is decomposition and the other one is autocorrelation function. If I but please be aware that for drawing the autocorrelation function, again we have to use a data frame data. So that's why I've came back to the first example, not a T-series, a data frame. If I draw the autocorrelation function, you can see that there is a repetitive pattern in the data. This graph is showing a seasonality. Okay, so it means that there is a seasonality and we have to remove it. And the second one is decomposition. using the decomposition, we have to define a time series with data. So that's why I've defined a time series with the date. And now I've applied decompose function. Okay. If I plot the decompose function, here you have this is the main graph. This is the main graph of the observation. And this part is the seasonality part of the graph, this part. So, and we have to, by subtracting the seasonality part of the observation, we will have a time series without any seasonality. So I've subtract the seasonal part from the main time series, just subtracting. If I applied it, now the final time series is the one which we are able to do modeling or anything or next steps on time series. Okay. Okay. You can for any further question, or if you need more explanation, or for having the R script, you can contact me easily. Also, thank you for your attention. Thank you for the participation, and please note that Our Ladies support any information sharing, and you can be in touch with Our Ladies, and these are the connections, and connect with us. Okay, thank you. And now I'm ready for your question.
Thank you so much. Very nice and informative presentation, dear Mahshid. Okay, let's see. We have one question here. I have a question. Why do you apply the log function in order to calculate the trend?
Okay. Osvaldo, dear Osvaldo, if I pronounce it correctly, taking logarithm from the time series is one of the most famous way to removing the trend from the time series. And at first, we have to usually try the logarithm, and if we won't have the best result, we will go to the second step. That's why I've chosen a time series which if we take the logarithm, again we have trend, so we will go to the, but in most of the time series, by taking logarithm, you will have a time series without any trend.
Okay, another question. Are you talking about Kendall correlation in your speech?
No. Kendall correlation is a different kinds of statistical methods. We are talking about Mann-Kendall. We are talking about Mann-Kendall statistical method for finding the trend. But please be aware that for finding the trend, not removing the trend. Mann-Kendall, not Kendall correlation.
Okay, and for the sharing of the slides and also the script will be on our GitHub page. If you follow us on Twitter or LinkedIn or also GitHub, we will have all the presentations, this one and previous ones. Also, we will put the video of today's talk on YouTube. You can find it later. So yes, we will share the video. Okay, any other question?
You're welcome, Osvaldo.
In time series analysis, removing the outliers always not a good idea, and we have to consider them in analysis.
Yes, we have to consider them in analysis, but it depends on the number of the data. If you have 200, in this example, we had 216 data in a time series. And by removing 4 outliers, we won't have any interrupt in the data. So it's okay. But again, I emphasize that it depends on your field. In hydrology, 4 data in 216 data is okay. But if we have in 216 data, if we have more than 10 outliers, yes, this is exactly correct, and we are not allowed to remove all of them.
Okay,
And you have to, it depends on you. You have to make decision about your outliers. And sometimes, if you want to modeling, especially nonlinear models, it's better to keep them. But if you are going to use linear models, it's okay. Usually, we remove them.
Okay, another question. In hydrology, outliers can sometimes carry some useful information. Must we remove them always? No, because in some of them, maybe it will be like they are like extreme values, so we should take care of them as well.
Yes, no, it's not a must. It's not a must. It's totally depends on the aim. If you are going to, yes, I've explained it. And if for nonlinear models, it's better to keep them. But for linear models, it's better to remove them. And also, if you are working on extreme values, if you are going to do flood prediction, drought prediction, so you have to keep them.
Okay. Any other? You can also follow us on these websites. Thank you again for your wonderful presentation, Mahshid June. Okay.
Thank you so much, and thank you for the attention. Vielen Dank alle. خیلی ممنون از همه.
There is another question. The ACF, the autocorrelation function. What do you mean by the ACF? Like,
yes,
question.
ACF is the autocorrelation function, and by plotting the autocorrelation function, we can see easily that if there is any when we have ACF analyzed, if there is a repeated and repetitive patterns in the data, it means that you have to prepare the data before anything else. So and the code, this is a simple code, ACF and then time series. But the point is that you have to work on data frame, not time series. And yes, if you want, I can show it again. Yes, just simple ACF. This is the code, ACF and time series and the data frame, and this is the graph. And as you see, there is a repetitive pattern. And also there are a lot of points which we can identify by using autocorrelation function. Like now we know that this is a short memory time series, and this is a nonlinear time series. But here we have to focus on characteristics. At first, seasonality. So the first point is seasonality we can get from the ACF.
There is a new package as TS Studio for analyzing time series data. Great. Thank you for letting us know.
Yes, thank you for sharing.